Welcome students. Let's see about the loss of energy in pipes in this video. When a fluid is flowing through a pipe, the fluid experiences some resistance due to which some of the energy of fluid is lost. This loss of energy is classed as major energy losses and minor energy losses. Major energy losses are due to friction and it is calculated by the Darcy Wayback formula or the chassis formula. Minor energy losses can be due to expansion of the pipe or contraction of the pipe or bend in pipe or due to pipe fittings or due to obstructions in pipe. So we are talking about resistances offered to fluids which are in motion, that means fluids which are flowing through pipes, and energy lost as a result of that resistance. So there are two types of losses, major energy losses and minor energy losses. Major energy losses are calculated by these two formulas, and the main reason of major energy losses is due to friction. Minor energy losses can be due to any of these 5 reasons. So let's see about the loss of energy due to friction. To find out the loss of energy due to friction from the Darcy Wayback formula, use this equation where HF is the loss of head due to friction, F is the coefficient of friction, which is a function of Reynolds number. It can be 16 by Reynolds number Re if Reynolds number is less than 2000, and it can be 0.079 by Re raised to 1 by 4 if Re is from 4000 to 10 raised to 6, that means above 4000. L is the length of the pipe. V in the equation is the mean velocity of flow, and B is the diameter of the pipe. Using chassis formula, the equation for loss of head due to friction is given here. So here HF is again the loss of head due to friction. P is the wetted perimeter of the pipe. Wetted perimeter means the perimeter which is in contact with the fluid. A is the area of cross section of the pipe. L is the length of the pipe, and V is the mean velocity of flow. So the ratio of area of flow and perimeter which is wetted, that means perimeter of the pipe which is in contact with the fluid, this ratio is called the hydraulic mean depth or the hydraulic radius, and it is denoted by the term M. So M is equal to A by P, which is equal to pi by 4 into d square by pi into d. Perimeter can be represented by the equation pi into d, where d is the diameter of the pipe. So finally M becomes d by 4. So substituting A by P is equal to M in the equation, we get HF is equal to F dash into L into V square by rho G into 1 by M, or it can be written as V square on the left hand side and HF into rho G by F dash into M into 1 by L, which can again be rearranged as rho G by F dash into M into HF by L. So here it was V square, we make it to V by taking square root, and it finally becomes square root of rho G by F dash into square root of M into HF by L. So let rho G by F dash the whole square root become C where C is a constant called the chassis constant. Then the term HF by L is denoted by I, where I is the loss of head per unit length of pipe. So the equation becomes V is equal to C into square root of M into I, where C is the chassis constant, which is square root of rho g by F dash. I is square root of HF by L, which is the loss of head per unit length of pipe. Okay, and M is the hydraulic mean depth or hydraulic radius. Okay. So loss of head due to friction in pipe from chassis formula can be obtained if velocity of flow through pipe and also the value of C is known. Value of M for pipe is always equal to B by 4. Value of M is always equal to B by 4. Let's see a problem. Calculate the discharge through a pipe of 200 mm diameter. The difference of pressure head between the two ends of a pipe 500 meters apart is 4 meters of water. Take the value of F as 0.009 in the formula. HF is equal to 4F LV square divided by D into 2G. So the given quantities are diameter of the pipe, which is 0.2 meters, length of the pipe, which is 500 meters, difference of pressure head, which is HF, as 4 meters of water, and F is also given, which is 0.009. Then using this equation, we know the quantities HF, F, L, then G is also known to us, D is also known to us. The only thing we have to calculate is V. So we get V as square root of 0.872, which is 0.934 meters per second. So if we know V and if we know area, we can obtain discharge, which is Q, which is asked in the question. So velocity into area gives Q. Velocity we already know, which is 0.934, and area is pi by 4 into d square. D is already known to us. So we get the answer as 29.3 liters per second. Next, let's see about the hydraulic gradient and total energy line. So this concept is useful in the study of flow of fluids through pipes. Let's see the definition. Hydraulic gradient line is defined as a line which gives the sum of pressure head and datum head of a flowing fluid in a pipe with respect to some reference line, or it is the line which is obtained by joining all the top vertical ordinates showing the pressure head of a flowing fluid in a pipe from the center of the pipe. It is briefly written as HGL, or hydraulic gradient line. So it is the sum of pressure head and datum head, that is P by W and Z, or it is a line which joins all the vertical ordinates showing the pressure head from the center of the pipe. Total energy line, it is the sum of pressure head, datum head and kinetic head of a flowing fluid in a pipe with respect to some reference line. So it is obtained by joining the vertical ordinates showing sum of pressure head and kinetic head from the center of the pipe. It is briefly written as TEL, or total energy line. This is the pictorial representation of the hydraulic gradient line and the total energy line. So this is the hydraulic gradient line, and above that you can see the total energy line, which is the TEL. Okay. So as said in the definition, you can see that there is a datum at section 1 and section 2, which is the potential head or the datum head, which is Z1 and Z2. That is a vertical height of the 2 points 1 and 2 on the pipe. Then there is a pressure head at the 2 points. So the pressure head marked above the center line of the pipe. The center line of the pipe is here. The pressure head marked above the center line and joined together will give you the hydraulic gradient line, and the sum of pressure head and kinetic head marked above the center line of the pipe will give you the total energy line. You can try out this problem. Thank you.